Yes, good evening, everyone. Am I audible? Am I audible to you? You can write in the chat box yes, no. Good evening, all. Okay. Okay, Varun. Thank you. So, welcome to this week 4 discussion. Good evening. So, this is the course Design of Photovoltaic System, which is being taught by Professor L. Umanand from Department of Electronics System Engineering, ISC Bangalore. And I'm Ravi Kumar, a PMRF Research Scholar at IIT Bombay. So, we were discussing in the last class about the radiation or energy on a horizontal surface at any latitude or on the surface of Earth. We have discussed insolation on horizontal surface. We have discussed energy on horizontal surface. What other things we were discussing in the previous class? Don't remember? We were talking about geometry. Geometry we have seen many angles. Okay, so these were the things which we were discussing, but here we were discussing on an horizontal surface, and now in this lecture or in this week we are discussing energy on a surface which is a bit tilted. Means if we have a horizontal surface like this, so we will discuss energy on this surface which is placed at a particular angle, and that is known as tilt angle beta. So what will be the energy on this surface? Then we will see air mass. What is this air mass is? What is the significance of air mass? Then we will see, other than that, we have, yes, atmospheric factors. So these are the few things which we are going to discuss in this class. So this is an horizontal surface which I was talking about, and this is a tilted plane, and this beta is the tilt angle. This beta is the tilt angle. Now this is the zenith, and this will be the normal to the tilted plane. And if we see this in an coordinate system, so this was the case. It was our zenith, and it was our equatorial plane, and it was the phi. Phi is the latitude of a place. So it was all about when we were discussing on horizontal surface. But now we need to like have it this tilt as well. So if we just combine this plus this, then we will get this. Now if this was the beta angle, this is the beta angle, that is a tilt angle, then how much angle it will be? This angle, this question mark, the angle will be, what is this angle? Angle X. If this is beta, then it will be beta only, because if beta will coincide with this horizontal plane, then this normal will coincide with this zenith, and due to this is equals to beta, and that's why this angle will be phi minus beta. Understood? So what we need to do to find the daily energy on a tilted surface, we need to replace this phi with the phi minus beta. In the same formulas which we had, we need to replace this phi with the phi minus beta, because now the surface is a bit tilted with the angle of beta. Now let's see the formula for the energy. So first we have seen this is the formula on horizontal surface, and we have done many questions in the next class, in the previous class as well. So here what will change? Will this delta change? Yes, no? No, it will not change. Will this phi change? Will this phi change? No. But effective phi will be changed. See, in the previous thing I told, First, this was the angle phi. Now we need to consider this angle as a phi, and this will be phi minus beta. So in the place of phi, we will be using phi minus beta. Same thing here, like these angles will change and this will not change. And this was the total energy. It is the insolation only. It was the total energy on horizontal plane. And here also we need to replace this phi as well as omega. Why omega will change? Because the plane is a bit tilted. Sometimes have you seen, like while during the sunrise or sunset, the sun is visible while you are on the top of your building or when you are on the terrace, but the sun is not visible when you are on the ground. So sunlight is depending on the plane tilt as well. So that's why this omega will change. So what will be the modified formulas for this insolation and daily energy? So this will be the formula for our daily energy. This is the for insolation. Here just phi is being replaced by phi minus beta. Phi minus beta. And in this case, same thing. This phi will be replaced by phi minus beta. And this omega, it will become, it will be like, because here also we have phi in the omega. And in this phi we can have phi minus beta as well. So we will take minimum of these two omega. So in this formula, first we will calculate this omega. We will see which is the minimum, and this minimum we will replace in this formula or in this equation, and then we will get energy. So this is all about the formula which we are going to use in solving the numericals. Now let's come to the other things, like what is the effect of atmosphere on incident radiation. Okay, what are the factors due to which this incident radiation is being affected? Write in the chat box, what do you think, what are the factors due to which light, or we can say sunlight, or we can say radiation incident on the surface on an horizontal plane is being affected? What are those factors? Just recap. It's a recap only from the last class. Write in the chat box, what do you think about? Is it location? Is it time of the day? Is it time of the year? Is it the tilt angle? No. You don't want to write it. Okay. So all factors are like location. Location means latitude, time of the day, time of year. Then we have tilt angle. We have atmospheric or atmosphere. So these are the few things due to which the radiation being affected. Then we have seen this latitude, we have seen this time of the day with the omega, this with del, this with beta. Now what is left is the atmosphere. How can we consider the impact of atmosphere in calculating the effective radiation on the surface of any horizontal plane? So this is the question which arises here. Have you seen this? What is this curve is? What this curve is? At least write in the chat box whatever comes to your mind. Even if you don't know, write no, we don't know. Okay, how many of you have gone through the lectures? Week 1, week 2, week 3, week 4. Are you guys writing or not? Or my screen is stuck? Let me check. So there are some regular students like Ruchi, Salani, Prabhakaran, Mayur. What about you guys? Have you gone through the lectures? Okay, Ruchi said yes. Salani said yes. Varun also said yes. Okay, great. So what this curve is representing here? Prabhakaran, yes. Okay, this is the sun radiation on Earth. Now tell me what is this black line and what is this red line? This is before atmosphere. This is after atmosphere. Black without atmospheric effect and red one is with atmospheric effect. Very good. Okay, so you can see this is the loss of, we can say, radiation. This is the loss of radiation. Loss of radiation. This is the loss of radiation. So there are so many radiation which is being lost due to this atmosphere. Why? What are the factors which are causing the loss into this incident radiation? Okay, first I will show you other factors. Factors were like this: location, time of day, time of year, angle, and atmospheric effect. Now tell me, in this atmospheric effect, what component do you think are responsible for minimizing the incident radiation? What is in our atmosphere is, okay, do you know which gas in the atmosphere is good for our health? Oxygen is good for O2. Oxygen is for our survival, but other gas is there which is good for our health, like medical effect. O3, yes, Salmi, O3. It is ozone. So first one is ozone. What ozone is doing? Ozone is absorbing high frequency radiation. So this loss in the radiation is due to ozone. Then other than that, what we have in our atmosphere? Just see towards the sky, you will see many things. Moisture. Moisture we represent with water vapors. Clouds, yes. Dust, we also have dust. And why due to this dust the incident radiation is being lost? What dust is doing to this incident radiation? Scattering. Very good. It is scattering. And then we have other gases. Yes. So these are the atmospheric factor we have. We have ozone cloud scattering due to dust and other particles, water vapor and other gases. Major part is being due to absorption. Means radiation is being absorbed. So this is all about the effect of atmosphere on the incident radiation. So due to this factor, the incident radiation is being lost. Now let's come to the very important concept that is known as air mass. What do you understand by the word of air mass? Air mass, mass of air. Okay, let me just give me one answer. I'm having a box with L length. I'm having a box with 2L length. Column of air extending from collector up to the upper limit of atmosphere. Very good. That is the air mass. And why this air mass important is because if I just have radiation at one side, same here, the radiation which will be coming out, let's say radiation 1, radiation 2, radiation 3, radiation 3, 4. So if R1 equals to R2, then R3 will be equals to R4. The radiation is passing through the box having atmosphere inside. One is having L length, another is having 2L length. Then the output from these boxes, or we can say air masses, will be same or different. This R3 will be same as R4, yes or no? No. Yes, it will not. Because here the radiation is just crossing this L length and here it is crossing 2L length. So effect of atmospheric factor will be double here, and due to which the radiation which is coming out from these boxes or in the air masses will be different. Good. And your definition is also correct. So let's understand with the view of this earth. So we have this our earth, then we have this atmosphere, and let's say this is 1. We are assuming the perpendicular path is 1 and this is non-perpendicular path is L. Then air mass is defined as L equals to 1 by cos theta z. What is this theta z? Which angle is theta z? Angle is being made with the zenith line, and the angle which is with the zenith line is known as zenith angle. So this theta z is the zenith angle. So the formula for air mass is 1 by cos theta z. It is just all about the direct optical path length, because path length is changing with the angle. That's why we have the concept of this air mass. And you can see here as well, if this theta is increasing, theta z is increasing means our zenith angle is increasing, and with increase in this, due to this, our air mass changes. You can see for 25 it is 1.1, for 48.2 it is 1.5, for 60 it is 2. Increase in air mass means angle, that is the theta z is high, and this theta z is high representing that the light is passing more, or light is having more optical length through the atmosphere. And in the case of difference in height, let's say you are calculating on a big building, you can say the tallest building in your city and at the sea level, then also this air mass will change. And to calculate this with regard to the pressure, we have this formula. So it is just like this: air mass 1 divided by pressure 1, air mass 2 divided by pressure 2. It is just directly related here. So this is the basic concept of air mass, and air mass is calculated using 1 by cos theta z, that is the zenith angle. Now we will see we have seen the air mass, we have seen the atmospheric impact. So in real life, if we have a solar panel placed this way, this is a particular angle, that is the beta, it is known as tilt angle. We are having different kind of radiation: direct, diffuse and reflected, albedo effect. So these are the three kind of radiation which is coming on the surface of this, and it is being tilted, and A is representing the impact of air or atmosphere. So the incident energy on this surface is represented with HAT. A means atmospheric impact, T means with a tilt. So this is just a representation in real life what is happening with our solar panels. So it is not like we have one incident radiation, that is a direct beam, and the direct beam having energy here 1.367, so it will be here 1.367 and we just calculate with this. No, this is not the case. We have different types of radiation. We have direct, we have diffuse, we have reflected, then we are at a particular tilt angle, then we have atmospheric impact. So these are the factors which affect the incident energy. So with this we have two more concepts, which is like one is known as tilt factor and another is known as clearness index. So tilt factor is the tilt factor. We can say the impact of tilt, the factor which is representing the impact of tilt. So simply we can calculate this as this way. This is the tilt factor. So daily energy on the tilted surface, daily energy on the horizontal surface without any tilt. So the ratio of this energy will be the tilt factor, and these are the formulas, and which we substitute like all the values from the like previous slide, then we will get this formula at last. We have another concept that is known as clearness index. So clearness index is also same thing. So we have without atmosphere energy and with atmosphere energy. So it is a ratio of energy with atmosphere and without atmosphere. And this is just different formulas. You have seen in the lecture as well how we calculate this HAT or HOT or H naught T. Then see, let us consider you are at your home and you want to find out the clearness index at your place. HD. HD is the due to this diffuse. See, these are the different components. This HAT will be having direct, diffuse and reflected things. So we means this HAT can be represented as a sum of three factors. One is due to direct beam, one is due to diffuse beam, and one is due to reflected beam. So HD is the energy, incident energy due to diffuse radiation. See, I have taken this, is the energy component due to diffusion. Yes, H is representing energy and the subscript is representing due to what factor. It is already written here like diffuse. Okay, so let us consider at your place you want to find out the clearness index. How will you go about it? What I told you, clearness index is KT equals to H with atmosphere, H without atmosphere. So without atmosphere, how can you calculate? And with the atmosphere, how can you calculate? You need to these two quantities, then you can solve it and take a ratio, then you will get this clearness index. How will you get this H naught? Can you solve this H naught at your place? Do you know the phi at your place? At any time, do you know delta? Do you know n? We can find out at which date you are calculating. So using all these, what can also you can find out omega, and using these angles you can calculate this H naught. Yes or no? Can you calculate H naught using these different formulas? Yes. Yes. Then how will you calculate this HA? HA you need to measure, because you cannot calculate HA using formulas, because it will be impacted by clouds movement, it will be impacted by wind, it will be impacted by dust. So many particles or things will be there. So there is a device that is known as pyranometer. Have you seen pyranometer? Anyone? In real life? No. Okay. So it is just a small device. It is just like that. This is the glass and this is the double glass, and here we are having sensor. So what happens when the radiation comes on this sensor? It results in some voltage which correspond to this insolation in watt per meter square. So it is a device using which we can measure the radiation. So to calculate this clearness index at your place, you will do these things. So it is just a daily energy incident on the horizontal plate with atmosphere and without atmosphere. So you need to get this HA and H naught. So you will do with the pyranometer, you will get this HA, and by using this angle you will get H naught, and then you will take a ratio. Now I saw on board. Okay. You can Google it, you can find out the images, you can easily see. It is a basic device and very reliable. Okay, so these are the concepts which we need to understand before doing the numericals. So it is all about the atmospheric impact. In this we have clearness index. Also we have impact of tilt, that is the tilt angle. Now we will solve few problems. So let's start with the question 1. Very basic question. What is the air mass index for the zenith angle of 30 degree? And these are the options. Calculate it and let me know. What is the angle? What is the formula for this question? What is the formula for this question? You need to calculate air mass index for the zenith angle of 30 degree. It means we are talking about this way. If this is the earth and this is the atmosphere and if this is the zenith surface and our sun is here and radiation is coming like this and this angle is theta z, which is given 30 degree. A. Mayur also said A. I got 2 answers. I need one more. Shalini or Prabhakaran. Varun. Just verify. Is it A? Air mass is 1 by cos theta 1 by cos 30 root 3 by 2 by root 3. Am I right? 4 divided by root 3, 1.155. Yes. Yes, it is 1.15. Yes, A. A is the answer here. Everyone understood? Okay, let's move to the next question. It says the insolation along the normal axis to the horizon plane is 1.36. One tilted horizon plane makes an angle 38 degree with the horizon plane. What is the insolation along the normal axis to the tilted horizon plane? These are the options. If you are not understanding the question, let me know. Tilt angle is given 38 degree, and insolation along the normal to the horizontal plane is given 1.36. You need to calculate the insolation along the normal axis to the tilted plane. Are you guys calculating this? Are you guys getting the question? If no, let me know. $1.072. You said 1.07. Okay. Others? B. Yes, it is B. It is very simple question. Like this is our horizontal plane, this is normal, and this is the radiation 1.36 kilowatt per meter square. So we have a tilted plane like this. It is beta plus 38 degree. Then we have a normal to this like this, and this is beta, then it will also beta, and you need to just calculate 1.36 towards this. So it will be just cos beta into 1.36, right? And if you do this cos beta cos 38 into 1.36, yes. So this is the answer P, 1.36. Now let's move to the next question, which says a solar collector is tilted at an angle of 20 degrees with respect to horizon plane at some locality. The latitude angle of the same locality is 30 degree north. What is the effective incident energy? It is asking energy in square meter per day collected by the solar collector on 20th May, non-leap year, without any atmospheric effects. LS is given 1.37. And these are the options. You just need to calculate the energy on the tilted surface, where beta is given 20, phi is given 30, or date is given, then you can calculate n. Let me know if you need formula, because I think for remembering the formula is a like cumbersome task here. Do you need formula, yes or no? If no, then solve it. If yes, let me know. Yes. See, this is the formula for daily energy without any tilt. And this is the formula with tilt. You just need to put the values here in this equation and get the answer. And for this you also need to calculate this delta. For this delta you can use this formula. Now give me the answer. First solve this delta. What is the value of delta? First let me know the value of n. What is the value of n? N is 140. Very good. What is the value of delta? Delta is 20.13. Only Salani is solving, not the other guys. Okay, it is 20.13 degree. Okay, so you have solved this for n. You calculated delta. Now calculate this omega SR and omega SR beta. Phi you already know, delta you already know. Just put it here and calculate omega SR. Ruchi Mayur, what is the omega SR? Prabhakaran is not active today. He is in the meeting, but he is not active. It's fine. Delta, yes, very good, Mayur. Delta, right. Ruchi said 102. So I guess 102 is for omega SR. Okay. 102.217 degree. And what about this omega SR beta? Omega SR 77.77. Salini, you are making some mistake. Let me solve then if you are getting different answer. 10 5 is 30 into 10 20.13 into minus 1.2116 inverse cos inverse 0.2 minus no sorry, WSR is 1.3. You are saying in radian. Might be. Okay. Ruchi said 102 it is fine. So this omega SR is 102. Let me check in radian as well. It is into 5. It should be 1.78 in radian. Because you just need to multiply by pi by 180, then you will get in radian. And if you do so, 102 into pi by 180, it is coming around 1.78. Omega, which omega? 1.7. Yes. SR. Omega SR, yes. 1.784 in radian, yes. It is corresponding to 102.217 in degree. Okay. Now calculate omega SR with beta. Because you need to take the minimum of this omega in the calculation. So calculate with the beta. $115.9. Means you are saying with the tan theta is decreasing and your omega SRB is increasing. Might be, let me check. But I don't think so it is right. 5 minus is 10 into 10 20.13 into minus 1.0646 inverse cos minus 646. No, wrong. Ruchi, it is not 115.9. 10 5 minus beta will be 10 delta will be 20.13. It is coming around others, please correct it. What is the omega SR beta? But for sure it is not 115. You must be making some mistake in calculation. Please recheck your calculation. Check if your calculator is on degree or radian. Mayur, you are calculated omega SR, that is right, but what about omega SR beta? Yes, Ruchi. It is 93.7. And mine is coming, yes, exactly same. So it is around 93.7. Now minimum is 93.7. What is in radian? Because here we need to put it here in radian. So what is in radian? 1.81. Let me check. Into 5 divided by 180. No, not 1.8. Just convert this 93 into radian, you will get some around, yes, 1.63. It is 1.63. Now put this beta and this radian here in this equation and let me know the answer. Also calculate this K. K will be calculated from here. LS you already know, it is 1.37 and 24 by 5 is already known. Put the values here and get me the answer. Ruchi said 1.63, that is correct. So in the final equation, that is this one equation, we know everything. We know this delta, we know this phi, we know this omega, not the omega, just omega SRT, SR beta, or we also know this K. K is just here, from here you can calculate K. So we know each and every variable here. You can just put the variables and get the value. Just put the variables and get the value. Shalini said 10.41. So one vote goes to this A. At least give me the three different, not the different, give me the three responses. Ruchi, what about you? Mayur, what about you? If you are having issues solving like all the things at a time, okay, yes, Mayur, omega is 1.63. So first solve this part, then solve this part, then add them, and then multiply with this. Three-step problem, yes. Okay, you guys are taking so much time. So, should I go further? Should I proceed? Just let me know, Ruchi, Mayur, are you guys solving it or not? If no, then we can proceed further. If yes, we can wait for you. K is 0.9754. Okay. Rasmi said 11.14. Okay, so it might be 11.14. In that case, you have not considered the like good amount of significant figures in your calculation, but yes, you can get 11.14 as well. And if you are getting 11.14, what will be the option you will choose? Which option will you choose? A, B, C, D? C. Why not A? The distance between this your answer and C is 4, and the difference between your answer and A is 1. Where is the minimum error? Yes, Rasmi, you should choose A. You can choose whatever you want, but you should choose A if you are getting 11.12. Okay, guys. So yes, A is the correct answer here. It is 10.4. Let's move further. Based on the previous question itself, in question number 3, what is the value of estimated hour angle in degrees of the day for the calculation of effective incident energy received by the solar collector if the tilt angle is changed from 20 to minus 20? And these are the options. So you need to get the hour angle if beta is changing from 20 to minus 20, then what should the beta for the day? Sorry, what should be the omega for the day? Hour angle for the day. For your simplicity, these are the formulas which we utilized before. So you have calculated or you have obtained one. Let me write beta. Here it was 20 degree. Here it was minus 20 degree. So what was the omega SR for this 20 degree? I think it was around 102, and omega SR beta was around 93. For minus 20, just calculate. Omega SR will be same, 102, because there is no component of beta here. Calculate this. Omega SR beta with beta minus 20. Give me the value of omega SR beta. Okay, you might be forgot about the 5. 5 was about 30 degree. Now give me omega SR beta. Okay, that's why you are getting 115 because you have taken minus. Yes, declination angle will be same. Because it is asking from the previous question itself. So previous question, the n was already defined, then this declination angle will be same. $115.9. Okay, I can write 115. Okay. So what should be the estimated hour angle for the day? What it says, minimum of these two. Before minimum was which one? 93 was the minimum. Now which is the minimum? 102. What will be the answer? You will choose this omega. Ruchi said answer will be 102. And I am saying that is wrong. 102 is not the answer. See, understand the question. It is asking estimated hour angle of the day. What is the hour angle in a day? For the entire day, hour angle is 2 omega. Because it is like this. Minus to positive omega, it is omega equals to 0, omega negative, omega positive. So entire angle will be 2 omega. Yes, yes, Salmi, you are right. So then what will be the answer? Two, three, one. Why? Minimum of 2. Yes, 204. Yes, one only. 204 should be the answer because you will utilize the minimum of 2. Here minimum is 102. You will do it twice, then you will get this 204. Answer is B. Okay, let's move to the next question. A solar panel is placed on a rooftop. It is tilted at angle 25 with respect to this origin plane. The ratio of the incident energy on the tilted plane to the incident energy at the horizon plane of the coordinate system is 0.95. If the clearance index is 0.75 and reflection coefficient is 0.1, what is the overall tilt angle? Oh, sorry, what is the overall tilt factor? And these are the options. See, I'm just writing what all information is given. It is given beta 25 degree. It is given the incident energy at the tilt angle at the origin of the local coordinate system. It means H naught T, we are also known as RD. It is given 0.95. Clearance angle is KT equals to 0.75. And then this reflection coefficient is rho equals to 0.1. So these are the factors which are already given. And you need to calculate overall tilt factor, which is defined by gamma. You might be needing a formula for this, and this is the formula. Omega t will be 1 minus hd by ha into rd hd by ha plus 1 by cos beta by 2 rho into 1 minus cos beta by 2. First calculate this hd by ha from here, then put it back here and put the values and calculate omega t. What is the value of hd by ha? Give me the answer. hd by ha. KT is given, just multiply 1.13 into 0.75 and subtract it from 1. Okay, I am just relying on your answer 1525. Be careful while doing the calculation. Okay, now omega t will be 1 minus 0.525 into what is RD? 0.95. Then plus HD by HA is 0.1525 into 1 plus cos 25 divided by 2 plus rho is 0.1 into 1 minus cos 25 divided by 2. It will be an overall tilt factor. So first solve for this. What is the value of this? Then what is the value of this? Then what is the value of this? And then add them. What is the value of first factor? 1 minus 0.525 into 0.95. Point 8051. What is the value of second factor? Cos 25 plus 1 divided by 2. Calculate in this order only. First calculate cos 25, then add 1 into it, then divide by 2. 0.9531 into 1 into 0.1525. Are you saying the entire second factor is 0.9531, or are you saying just 1 plus cos 25 by 2 is 0.9531? Let me solve. Cos 25 plus 1 divided by 2 it means you were saying only 1 plus cos 25 by 2 is now into 0.1525. It is coming around 0.1454. What is this 0.955? Have you multiplied with 0.1525? No. Then again cos 25 minus 1 divided by 2 into minus 0.1. It is 0.005, or we can say 47. Now just add them. Plus 0.8051 plus 0.1454. I got the answer. Oh, you are saying 0.955 is the overall answer. Saloni. Yes. Okay. Yes, if you will add them, you will get 0.955 answer. That is the option A. Let's move to the next question. And in this question, I won't give you a single hint. Yes, Rasmi, it is the right answer, 0.955. So it says a man of 5 feet 11 inch is standing under the sunlight. The length of shadow of the person with the on the ground is 50 centimeter. What is the air mass index from the following? And these are the options. And trust me, you don't need any hint for this question. It is the simplest question. It is the simplest question. A man is standing here. This is the man. 5 feet 11 inch. This is the shadow, 50 centimeter. PM need to calculate. 3.74, 1.05. Rasmi said 1.05. Ruchi said 3.74. Even 3.74 is not in the options. It is AM 1.04. Yes. Rasmi, Mayur, both are correct. B is the right answer. Ruchi, you understand this? 5 feet 11 inch. How much inch? 12 into 5, 60, 71 inch. In centimeter, 71 into 2.54 centimeter. You just need to find out the ratio of this to this. So let's say A, B, C. So our AM will be C divided by A, and we can get it like this: under root A square plus B square divided by A. So if you will solve it, you will get 1.04. Answer is B. Now let's move further. Next question says, a Fourier series based approach has been made to estimate the clearance index of a locality for the set of given inputs. It is expressed as A1, A2, A3. Then A1 is represented like this: I12, I2 and I3, where I is 1, 2, 3. What is the size of coefficient matrix of unknown variables? These are the unknown variables, and these are the options. You need to just find out the size of unknown variables. I'm not understanding what is stuck in this question. It is saying A1, A2, A3, and corresponding to AI, let's say it is having AI1, smaller a, AI2, AI3. So it will be for like this. For all three, it will be A11, A12, A13. Then it will be A21, A22 into A23. It will be A31 into A32 into A33. And also we have this KT with 3 more factors. So generally what happens, if there are three factors here and in single 3 there are three different factors here, you just multiply them. 3 into 3 will be 9. So it will be 9 cross 9. See, this entire term is 3 and this A1 is already having 3 factors. If entire terms is having 3 and single term is having 3 factor, so overall factor will be 3 into 3. That is 9 and variable will be 9 into 9. You just multiply these number of factors with the number of factors, so you will get the matrix size. So it will be 9 into 9. If it is like, let's say KT equals to A1 plus A2 sine tau plus A3 cos tau plus A4 cos tau. If it is like this, and here we are also having AI, A4, then what should be the size? 4 into 4, 16. So it should be 16 cross 16. But in this
Sir, can you explain once again, sir? This is not clear actually.
Okay.
Not able to understand.
Okay. See, if you put this A1, AI, A2, A3 value here in this A1, A2, A3, so it will be like A1 having 3 factor, A2 having 3 factor, and A3 having 3 factor. So it's already there are 3 factors and 3 factors are coming inside. So it is like 3 and 3 factors inside. Then it will be 9. See, this is a complete, depending on the see. If you will see the lecture, you will understand. Even the professor have solved a complete problem on this, like how can we solve using the our like any programming language, because it is not easy to handle all these variables. But here just understand, if number of variables and inside a single variable we have more variables as well. It's like A1 having 3 more factors. So it is like one factor is having 3 more variables, one factor is having 3 more variables, and one factor is having 3 more variables. So if 3 into 3 will be 9, so total variables will be 9 into 9. Okay, and what about this? If it is having, like, let's say A1, we have 4 variables inside. Like if it is A1, A2, A3, A4, and we are having A12, A1, I2, AI3, AI4. Then one single variable is having 4 factors, and this is itself is a 4 factor variable. So it is 4 into 4. It means 16 cross 16 variables. You just go through the lectures, you will understand. It is just about the coefficient matrix. So answer here is C. Okay, the simplest question. Which of the following significant factor is responsible for this attenuation of spectral irradiance in infrared region? So this is the infrared region, these factors. As notch in this section, it means it is asking what is the significant factor which is affecting this incident radiation in this IR region. D. That's me saying D. A cannot be because it is in the higher side. Clouds, scattering, or water vapor. We are having all three, but major component is water vapor. D is the right answer. Let's move further. It says the direct optical path length of insolation through the atmosphere defined by air mass coefficient at the sea level is 1.5. It means at sea level it is 1.5 am. What will be the zenith angle formed by the zenith axis and the insolation line for the, it is saying particular location, that is ISC Bangalore, which is located at a certain height from the sea level. Let us consider the pressure at 920 millibar. And these are the options. So you need to calculate the zenith angle when the air mass at sea level is given. Will you do it, or let me give you the formula? It is Rashmi, you said D for this question. I think it is for revision. Okay. See, at sea.
The previous one. That was a previous one, sir. Not this one.
Okay. So in this question, it is saying at sea level, this AM is 1.5, and at a particular height, let's say here, the pressure is 920 millibar, and it is asking here what should be the theta z is that particular location. See, I told you in starting as well, AM is 1 by cos theta z, and also there is a relation like AM1 divided by P1 is equal to AM2 divided by P2. So you, let's say 1 is the sea level and 2 is the our location. What is the pressure at sea level? What is the pressure at sea level? One, or we can say 1000 millibar. Like absolutely it is 1025 millibar, but let us say 1000 millibar. And at our second location it is 920 millibar. AM is given 1.5. You need to calculate AM at 2 first, and then put it here in this formula, calculate theta. So what is AM2 and then AM2 and then cos theta z? I will also solve. It is saying 920 divided by 1000. Okay, I got the answer. What about you? Just calculate AM2 first and then theta z. P1 is given 1000, P2 is given 920, AM1 is given 1.5. What is AM2? Okay, Mayur said this. We got one answer here, 43.56. Ruchi said 52.16. What is the value of AM2 you guys are getting? Let me check if the problem with the like calculation or problem with the which part of the calculation. 1.63. Ruchi, what I told you, it is like 920 and P2 will be here. It will be P2 divided by P1, 920 divided by 1000 into 1.5, and you are doing it other way. You are doing, I think, 1000 divided by 920 into 1.5. Rashmi said 52.16. Rashmi, what is the value of PM or AM2? AM2 will be 920 divided by 1000 into 1.5. So it will be less than 1.5. What is the value of AM2? $1.38. Yes, absolutely right. 1.38 is the value of AM2. See, just understand, the air mass can be maximum at sea level only. If we are at a height, then this column will decrease. So our AM, air mass, will also decrease. And theta z will be 43.56. Mayur was right only, so it is C. Rasmi, Ruchi, are you getting the right answer or are you struggling with the calculation?
Yes, sir. Now understood.
Okay. So next question. It says it is a like second class pyranometer. This is a model of pyranometer which is provided with a spirit level. Spirit level is just to balance, and 4 plug having like 0 to 10 volt signal, so it can produce from 0 to 10 volt signal output. It is connected with this DMM, we can say the module, and power supply as shown in the figure. This is the power supply, how it is being connected. To read the signal, the load resistance kept, it is the load resistance which is being kept more than 1000. The pyranometer is mounted on the terrace. So this pyranometer is mounted on the terrace of a building where no obstruction exceeds the horizontal plane. It means there is no obstruction to the incident radiation. The instrument output voltage measured with this digital multimeter is 4.8 volt. So the output coming is 4.8 volt. What will be the display on the pyranometer in watt per meter square? And from the data sheet, it says the 10 volt corresponding to the 2000 watt per meter square, the radians. And these are the options. Simple question. Just words are more, but question is simple. Rasmi said 960. $960 is the one answer here. Only one answer? Zero to 10. 0 to 1000. 2000. If 10 corresponding to 2000, then 4.8 will corresponding to what? Just 4.8 divided by 1000 into 2000. Sorry, 10 divided into 2000. So it is 4.8 into 200. 4.8 into 2 is 960 is the answer. 960 is the answer. See, there is nothing to be taken in consider the load resistance and all. Just understand a pyranometer full scale is 0 to 10 and our calculated value or which is the maximum irradiance it can display is 0 to 2000. This is for confusing all. In this question, nothing to be needed, this load resistance and all. Okay, so actually we are done with this lecture. So do you guys know about this PV education or PV CD-ROM? pveducation.org. I'm just typing here. PV. Do you know guys about this website? Yes, no? If not, then I will just suggest you to just search on the internet and see, because this is a dedicated website to the PV field and here you will get everything from the basics of solar cell to the system. And interesting part is that it is having many animations which is easy to understand. If you want to see the impact of any factor on the output of a solar PV, you can change the factor and you can see what is the impact on the performance of solar PV. Yes, do so in next class or sometime we will also do here as well, and we will see what other things we can learn more. Yes, we will do sometime. Solution of future quizzes or the previous quizzes? You don't need to get the solutions, you can solve them. Okay, then take care. We will meet in the next Friday, and we will solve more questions and more problems. And just for your information, you guys must also be receiving an email mentioning the solution to the previous quizzes which the answers have been out. And if you are not receiving such emails, then you can go through the dashboard and you can find out the links for the solutions like for the previous quizzes. Okay, thank you everyone. We'll meet in the next class.